It's something that you have to get used to doing that's kind of difficult. So as a review here, what we're going to be doing is rather than worrying ourselves about finding the slope of a tangent to a function at one specific point, what we would like to do is come up with an expression you can use to find the slope of the tangent at any point. What does that mean? Well, if I take a look at the question that JV had asked about, which had x squared minus 6x plus 5, is my memory right on that? X squared minus 6x plus 5? And it was at x equals 2. If f of x equals x squared minus 6x plus 5, and I said to you find the slope of the tangent when x is 2, you could do that whole thing we did, right? But let's say I turn around and immediately after that I go, okay, what about the slope when x is 3 or negative 5? And what you would need to do is do that whole process for x equals 2, and the whole process for x equals 3, and the whole process for x equals negative 5. Or you could do what we're going to finish today's lesson with, which is to determine that the slope of the tangent at x equals a will always be in this particular function 2a minus 6. I guarantee it. Go ahead. Don't forget, this is really a. We're going to change it to x later. But if you put 2 into this expression for a, can you confirm that you get negative 2, which was the slope of the tangent? Yes? Do me a favor and put 3 in and figure out what you get for a slope. 0, right? 2 times 3 is 6, minus 6 is 0. Put negative 5 in. 2 times negative 5 is negative 10, minus 6 is negative 16. So now I'm going to show you something on your calculator that I've been putting off on showing you. And then we'll get back to this lesson. So again, the point is that we want to be able to do this today. We want to be able to find the slope of the tangent formula for a particular function. I'm going to enter into my graphing calculator the function of interest here, which is x squared minus 6x plus 5. And for those of you that haven't had me as a teacher before, I will very often do this. I don't know why. Doesn't really matter. Instead of writing x squared or entering x squared, I'll put xx because x times x is x squared. So I've entered x squared minus 6x plus 5. And let's go zoom standard, which is zoom 6. There it is. I'm going to adjust my window settings a little bit. I'm going to go to my window settings and change the maximum y to 75. It really doesn't matter. I just want a better picture of the parabola. So in the calculate menu, one of the options, number 6, has this. It looks like dy divided by dx, but that's not how we pronounce it, and it's not actually something divided by something. It's a little more slippery than that. We will learn about the details of this on Wednesday. But you can think of that as meaning the slope of the tangent. So if I hit enter, my calculator just hangs around waiting for me to enter an x coordinate so that it can calculate the slope of the tangent. So I'm going to put in negative 2. I'm going to put in positive 2. And it tells me that this dy dx thing is negative 2. It tells me the slope of the tangent is negative 2. If I repeat the process, I'm not sure I have to go back in here and do it, and I put in x equals 3, it tells me the slope is 0. So I'm telling you that you have this handy little thing that you're allowed to use for exams, your graphing calculator, that can always find slopes of tangents. If I put in negative 5, I'll just try it without doing it. I think I can, yeah. It gives me, I I guess it's just giving me a y coordinate now. I do have to, if I want to find another slope, I have to repeat the process and go back into calculate and then enter the x coordinate, and you can see you get negative 16. It was negative 16, wasn't it? I believe I said negative 16. I just wrote negative 6. Okay. So there will come a time where you will be able to look at this and tell me immediately without much thought that this is the equation you would use to find the slope of the tangent. I'm just curious how many of you think you know how to do it. It's iffy. You'd probably need another example to confirm your suspicions. But whatever you have, and I'll give one more here, just to satisfy your curiosity, those of you that think you know. If I said to you that f of x was that, I don't know that you'll get it, but do you think you know it? So rather than me asking you what you think, I'm just going to write down what it would be. The slope of the tangent at x equals a would be 6a squared minus 10. So it's probably maybe a little more complicated than you initially thought, but there's some connection between the function and the equation of the slope of the tangent. And I can see I got some of you thinking now, trying to figure it out. We won't actually learn this rule, it's called the power rule, until Thursday. Okay. So let's get started on this lesson. As a review, and I don't know what was wrong with me when I was typing this up this semester. I've got typos all over the place. A bunch of word typos there. Recall from the previous lesson that you can find the slope of a tangent to a function by using limits, and there are two different formulas you can use. If you understand where they come from, namely that q is approaching p, then that will give you a better success rate in using these formulas and applying these formulas. So we're going to do two very quick examples here using these formulas, and this will tie nicely into your assignment that you will be given in about half an hour or so. That will be due Wednesday. First of all, I believe in your handout it says f of x equals, in the warm-up, 3x squared plus 9x minus 15. Is that what it says? It should say plus 4x. And again, the day that I worked on this particular lesson, I was obviously didn't have enough coffee or something. There's typos all over the place. So use Formula 1. What's Formula 1? Formula 1 says the limit as x approaches a of f of x minus f of a all over x minus a gives you the slope of the tangent. And just for my information, I want to make sure that I have those two formulas written correctly on this page in your handout. And they're okay. So we want to use Formula 1 to find the slope of the tangent. Well, this one is a little bit easier than the H formula because f of x is simply the function. This will be the limit as x approaches a of the function 3x squared plus 4x minus 15 minus f of a, which is the y coordinate of the point. So that's what goes on the numerator of our argument for the limit, f of x minus f of a. Over, we're going to have x minus the x coordinate, which is x minus a, or x minus negative 2. So does anybody have any questions on the setup for that? Does that look reasonable to you? Very simple question, really, because when we simplify the numerator of this argument of the limit, this is something you're going to do. I wrote x approaching a. A is, in fact, negative 2. So at some point, you have to recognize that you're putting in negative 2 here for a as well. And I could have put it in a the line above it, and I probably should have, but it's not really that important. As long as you remember that that's what you're going to be substituting eventually. We have 3x squared plus 4x. What do we have? Negative 15 minus negative 11 is negative 4. And this is over x minus negative 2, which is x plus 2. Now, taking you back, and for you three at Buck Mountain, this, I don't know if I've talked about this with you yet or not. I think I have. But taking you back to, say, when you had me as a teacher in Math 20, for those of you that did, I taught you the kind of secret of deciding whether something that is quadratic is factorable. And it's that if you calculate b squared minus 4ac, if it's factorable, then you will get a perfect square. So what do we get when we apply b squared minus 4ac to the numerator of this? We get 4 squared minus 4 times 3 times negative 4. I think you're going to get 64, but I don't know. Can you work that out for me, please? I'm pretty sure it's 64. I'm starting to see some nods. So this is 64. Now, it turns out that this little bit of business that I'm talking about here is totally unnecessary, and I'm about to explain why. We know this is factorable based on that, so let's see what happens. This is the limit as x approaches negative 2, and we get into a trial and error mode here, where we say we know it's factorable, so I'm going to guess that this is 3x and x. And then you say, I need to put two numbers in that multiply to give 2. Now, why would I not try this, even though I know some of you would say you wouldn't try it because it's wrong, because you're able to factor things so quickly. But why would I not consider that? Makai? Oh, correct. What I meant to do, why would I not consider this? You're right. I have to have numbers that multiply to give 4, not 2. Why wouldn't I consider that, Arden?
Because it would have to factor to the, or it would have to be canceled by the bar.
Right. I know that this limit exists. We're going to go in circles again. I know that this limit exists because the tangent exists, and this is the slope of the tangent. And if the limit exists, then it's got to be possible to get rid of the x plus 2. It has to be. Which means one of the factors has to be x plus 2. And this takes me to my point about not having to do this at all. Look, if you have confidence in your math abilities, and I know that it's not always 100% confident. I'm not 100% confident all the time. But if you feel that you haven't made any mistakes, then one of these factors had better be x plus 2. It has to be. And that means the other factor, well, we would need a 3x to give us 3x squared, and we would need another 2 because 2 times 2 is 4. And I would ask you just to confirm. And we have to have a negative 4, so this would have to be negative 2 to get negative 4. But we need an x plus 2. This is infallible, this idea that there has to be a factor on the top that matches the factor on the bottom when you use this approach. Can you do me a favor, please, and FOIL out mentally in your head those two factors and confirm that you get 3x squared plus 4x minus 4? You do. You have to. You have to, because you have to get 3x squared and you have to get negative 4, and those two factors have to cancel. So anyway, these cancel, and now I can put negative 2 in. There's nothing preventing me from evaluating this argument at x equals negative 2. So the slope of the tangent will be 3 times negative 2 minus 2, which I think, although I'm not really off to a great start today, I believe that's negative 8. Am I right? Okay. Well, let's do the same thing, but let's do formula 2 now. We still have the same function. The function is 3x squared plus 4x minus 15. And we are using this formula now, the limit as h approaches 0 of f of a plus h minus f of a over h. And point P was at -2 comma -11. So don't forget that this is A and this is f of A. So the work in finding f of A would be accomplished by putting that A coordinate of -2 into the function, but we don't need to do that because it's already there for us. What is f of A plus h? Well, again, just like the ones we did earlier, I'm going to go ahead and put A in. So this is my, I don't know what to call it. This is my first level of customizing this formula for this question. It's to put in the specific value of A, which is -2. Do you have a question, Evan?
Do you recommend always putting it in the form A plus H, or is it, I don't know, maybe it's just my brain trying to make it simpler, but is it not easier to write H minus 2?
However it works for you. Yeah. Where we are going to go with this, though, the question was, do you have to put -2 plus h, or can we just write h minus 2? The answer is it doesn't matter. But you're going to end up seeing it as a plus h, because when we do the final question in this lesson, where we want to find a formula for the point anywhere, we're not going to put in a specific number. We're just going to write the letter A. And it appears as a plus h almost exclusively. Could you write h plus a? Yes. I think the reason it's written this way, instead of saying h plus a in that first argument of f, is that when you talk about that point P, which is at a comma f of a, and then you talk about that point Q, what we're doing is we're taking this a coordinate and we're adding h to get to that x coordinate of Q. And I think that's why we typically write a plus h. But no, it doesn't matter. Whatever, what you initially said is maybe it's just me and it makes more sense this way. If it makes more sense to you and it's correct, do it. Yeah. All right, so what is f of -2 plus h? Well, f of x was 3x squared plus 4x minus 15. So f of -2 plus h is what we get when we replace the x here and here with -2 plus h, giving us this next line, the limit as h approaches 0 of 3 times -2 plus h quantity squared plus 4 times -2 plus h minus 15. So what I've got written there is the result, and I would rather over-explain it than not explain it well enough, is I've taken these two positions and I've changed them to -2 plus h. I've done a substitution. Don't forget, and this is a very common mistake, you get caught up in the a plus h thing and then you go, oh, over h. Then you remember what I said, which is that you have to be able to factor an h out of the numerator in the end. So you simplify the whole numerator or do what Evan had described earlier by factoring it differently. And you discover there isn't a common factor of h. What have I neglected to include here? What have I forgotten about? That it is a common mistake, Zebby. I've forgotten minus f of a, right? And f of a is the y coordinate at that point, which is -11. So I have minus -11. Now keep in mind, Evan, that factoring 3 times negative 2 plus h quantity squared plus 4 times negative 2 plus h minus 4 is maybe more difficult even than what we described earlier. But I hope you see this is the same thing we factored in the previous method when we used Formula 1, isn't it? I'm not going to do it that way. I'm going to FOIL it all out, which is what most people would want to do. This is over h. Yes, you've got to write limit as h approaches 0. So I'm going to FOIL this out. I need to take 3 times the product of negative 2 plus h times negative 2 plus h. So this is what's going on in my head. That's me. I'm taking negative 2 plus h and multiplying it by negative 2 plus h and getting 4 minus 4h plus h squared. Double check that line. Negative 2 times negative 2 is 4 minus 4h plus h squared. Then I have 4 times negative 2 plus h. Where you multiply that 4 through is up to you. The only reason I didn't do it right now is I have to multiply this 3 through as well, so I thought I'd do all my multiplication in the next step. And then I have minus 4. And this is over h. So now we're getting really close. 3 times 4 is 12. 3 times negative 4h is negative 12h. 3 times h squared is 3h squared. 4 times negative 2 is negative 8. 4 times h is 4h. And then I have minus 4. You'll notice in terms of the constant terms, you have just as much good as you have bad. You have just as much positive as you have negative. You've got positive 12. And then we also have the negative 8 minus 4, which is negative 12. So these 3 terms collectively add to 0. Minus 8 is 4, minus another 4 is 0. Could we factor the h out right now? Sure. I'm going to follow kind of the standard process of simplifying that argument completely. It's the limit as h approaches 0 of, what do we have? Negative 8h plus, I believe that should be 3h squared, shouldn't it? Yeah. Not cubed squared. 3 times the h squared give us 3h squared. So plus 3h squared over h. Now I have a little bit of a question that I want you to just ponder. You don't need to answer it. But ask yourself in your head if it makes sense to you that the only term on the top that will ever be important at this point will be the term that is linear in h. The reason is if it's quadratic in h, there's an h squared, and we're about to factor h out. If you factor h out of h squared, you're still left with h's, which in a second is going to become 0 because h is approaching 0. Anyway, finishing this off, limit as h approaches 0, I can take an h out and have left negative 8 plus 3h over h. The h's cancel as factors, and we put 0 in for h and get negative 8 plus 3 times 0. All right, I think I've finally warmed up. So you get negative 8, which is what we got before, correct? So that's just a warm-up. And again, your assignment that you're going to be working on for Wednesday is related to that. I'm sorry. Does anybody have any questions with any of the work we did in the second part of this warm-up, part B. You guys are okay at Buck? Good. No problems here? Okay, so let me go through this explanation again of what we're doing now. We're going to be finding the slope of the tangent to this function at any point the function is defined. So in the above example, what we did was we found the slope of the tangent to this function at x equals -2. If I said, well, what is the slope of the function at x equals 3, you'd have to repeat the process. At x equals -11, you'd have to repeat the process. So that what we're after here is a following kind of idea, that the slope of the tangent will be equal to some function of the x coordinate. I want to go back and make sure you understand what I'm saying here. There it is. Remember this one where we had the function f of x equals x squared minus 6x plus 5. And I said, it turns out this right here, this is how we could calculate the slope of the tangent anywhere. We're after the equivalent thing here, and this thing is a function of that x coordinate. And Evan, you kind of thought you had it figured out, maybe? Without asking you to volunteer your thoughts here, do you have an idea for what you believe it might be for this one? And again, I don't want you to volunteer your thoughts. I'm just wondering if you have an idea. The second term is +4. It's the first term that we're unsure of. Anybody else have an idea? I'm not asking you to tell me. I want you to keep it secret. You think you do? Okay, so write it down and we'll check. We'll see if it works later, if it matches our work. So how are we going to do this? Well, see, normally we would use this formula, the limit as x approaches a. But in order to do this general thing, you have to use the h formula. You have to. There's no, well, sometimes the x approaching a formula works and it's really easy. Sometimes it works, but it's really, really difficult, and sometimes it just doesn't work. Okay? So the h formula is the key here. This is the limit as h approaches 0 of f of a plus h minus f of a over h. Now, it's at this point in all of the questions we've been working on. Focus up here, please. It's at this point that I put in the number for a. Right? I think in one of the questions we had -2 here for a. So we rewrote it as f of -2 plus h minus f of -2 all over h. But we don't know a. So we're just going to leave it. There's no first step here. Well, there is, but it's what was the second step before. Well, if f of x is 3x squared plus 4x minus 15, f of hearts would be 3 times hearts squared plus 4 times hearts minus 15. F of kitten would be 3 kitten squared plus 4 kitten minus 15. I suppose f of a plus h would be 3 times a plus h quantity squared plus 4 times a plus h minus 15. When we did this, and I'm sure there was one where we had -2 plus h. It might have been the very last example. We ended up putting -2 plus h everywhere there was an x in the expression. Well, we were putting in a plus h. We had this conversation about, can I write h minus 2? But it's a plus h. So again, what I'm doing here is every place I see an x in the function, I put a plus h. And then it's minus negative 11. Last example, it's still stuck in my head. F of a is what we get when we put a in for x. Thank you. So when I put a in for x, I'm going to have 3 times a squared plus 4 times a minus 15. That's a pretty serious mistake, sorry. Good now? Okay. So the fact that we have a's up here doesn't change the idea that h still has to be a factor. So you have to factor this whole thing out somehow. And I think now looking at it, I don't think we can factor it the way you were thinking before. Because we don't have that single number anymore. We have another function of a. So what you have to do is multiply this whole thing out. Sorry, I got too much going on here. You're going to have to FOIL this out. You're going to have to expand this out. You're going to have to remove those brackets and see what we get. So this is the limit as h approaches 0. I'm going to just write that a plus h squared on the side is a squared plus 2ah plus h squared. So I'm taking a plus h times a plus h. Okay. Then I'm going to multiply it by 3. You know what, everybody? I just don't want to rewrite that whole thing so that I can put this in and then multiply it by 3. So I'm going to have 3 times a squared plus 3 times 2ah plus 3 times h squared. So we'll double check this. A plus h squared is a squared plus 2ah plus h squared. Would you agree? Because it's a plus h times a plus h. I multiply each of these terms by 3 to get those 3 terms. Then I have plus 4a plus 4h minus 15. Then I have minus 3a squared. I have minus 4a, and I have minus negative 15. So I'm distributing, everybody, this negative into that trinomial. This is over h. What are the terms that don't have an h in them? This one doesn't have an h. But there's a minus 3a squared here, which is good because we don't want any h's. We don't want any terms that have no h's. We also have a 4a. And over here we should have a minus 4a. We have a negative 15 and we have a positive 15. So the only 3 terms we have left all have h in them, which means we'll be able to factor that h out. Leaving me with the limit as h approaches 0 of, what do we have? 6ah plus 3h squared plus 4h. Mackay, I'm just curious, are you starting to see what you thought was the answer in there? Namely 6a plus 4. Is that what you maybe thought it was? 6a plus 4? So now I can factor an h out. Again, it's the limit as h approaches 0. Don't take out 2h. Well, I guess you can't because there's a 3. Only take out the h regardless of anything else that's factorable. That's all you care about. Leaving me with 6a plus 3h plus 4. The h's cancel, leaving you with that limit. And now, because h is no longer in the denominator, we can put h equals 0 in and get 6a plus 3 times 0 plus 4. So the slope of the tangent to this function at x equals a is 6a plus 4. And luckily, we're going to graduate beyond this stupid limit formula. You'll do what Mackay and I know we could do to this function. That trick, though, Mackay, is only going to work if it's a polynomial function. There are other rules that we have to understand. This question, this example, is really a prelude to Wednesday's lesson. Wednesday, we will formalize this by talking about something called the derivative. Any questions with that example? Okay. So your practice problem has two sets. If you feel you have no difficulty in finding slopes of tangents at specific values of x, then you certainly don't need to do any of the additional problems. But every time I teach this, somebody says, well, can we get extra practice? So on pages, I think 22 and 23, I can't remember. Doesn't matter, the pages are the next pages. There's a whole bunch of different ones that you can try with both of those formulas. The ones I would like you to practice for sure are these two on page 36 of your textbook, and what they involve is what we did in this example, finding the general formula. The rule that you figured out, Mackay, and maybe we can just, reveal it to everybody, could be used for both of these, but it would not be usable for more complicated things. Do you believe you know, for question 9, what you would do to A to find the slope of the tangent? Sorry? What is it? It is 2x plus 1. And I like that you said 2x plus 1. I'm going to write 2a plus 1. On Wednesday, we're going to throw our hands up and say, why are we writing a? It's x, and we will write 2x plus 1. Has anybody else caught on? Okay, Mackay, we'll stick with you. What do you think it is for number 10? It is 6x plus 2. And again, I really want to write x, but in this part of the lesson, we're sticking with a. You take the old exponent of 2, multiply it by the coefficient, that gives you the 6, and you drop 1 from the exponent, making it 6x to the 1. And that's, your suspicions are confirmed. Over here, if I multiply the 1 by the 2, that gives me a coefficient of 2. And I drop 1 from the exponent, giving me x to the 0, which doesn't need to be written. It'll only work for polynomials. It won't work all the time for other functions. Anyway, give these two a shot. I'm going to hand out your assignment now that is due Wednesday. If you want to try these two in class and leave the assignment for later, that's fine. If you want to work on the assignment now and leave these for later, that's fine. Your call. And Nicole, Demi, and Zach, I believe the assignments are printed out in there for you. So somebody's going to, oh, you got them already. Perfect. Thank you. So I'll hand them out here and you guys can get to work. Absolutely.